Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn Class 9th Chemistry Chapter Solutions Part 3. In this part, we are going to learn about solubility. Solubility. So, the solubility of a substance at a given temperature is defined as the quantity of that substance that can be dissolved in 100 grams of the solvent at that temperature to get a saturated solution. The formula for finding solubility is as means solubility is equal to weight 1, that is weight of the solute in grams, and weight 1 upon weight 2, it is the weight of the solvent in grams into 100. So let us solve a question based on this. The question says that 5 gram of a salt dissolved in 20 gram of water to form a saturated solution at 60 degrees Celsius. Calculate the solubility of the salt at this temperature. So, salt is 5 gram and water is 20 gram. The major component is solvent and minor component is solute. So over here 5 gram is the minor component upon solvent. The major component is 20 gram. We have to find the solubility. So weight 1 upon weight 2 into 100. Always we have to write this formula above, below the question, is equal to solubility. So 0 0 cancels, 2 1s are 2, 5s are 10. 5 into 5 is equal to solubility. Therefore, solubility is equal to 25. Twenty-five is the solubility of this salt at the temperature 60 degree, as it is given in the question. I hope you have understood. Like this we have to solve the solubility questions. Now let us move towards the next, that is factors on which solubility depends. Now there are factors on which solubility depends. Depends. Now first factor is nature of solute and solvent. Nature of solute and solvent. First, polar compounds and ionic compounds are soluble in polar solvents. Example, ionic compounds like common salt dissolve in polar solvents and the solubility is found to be 311 gram per liter. B. non-polar compounds dissolve in non-polar solvents. Example, covalent compounds like methane dissolve in non-polar solvents like carbon tetrachloride. Exception. Certain covalent substances like non-polar compounds can also dissolve in water, as water can form hydrogen bonds with the substances. Second is effect of temperature on the solubility of solid in a liquid. Effect of temperature of temperature on the solubility of solid in a liquid. So there are two. First is exothermic solution formation and second is endothermic solution formation. In exothermic solution formation, some solids on dissolving in a liquid release heat and the solution formation is exothermic in nature. For such solutions, the solubility decreases on increase of temperature. Example, serous sulfate, Ce2SO4 3. Endothermic solution formation. So some solids on dissolving in a liquid absorb heat energy and the solution formation is endothermic in nature. For such solutions, the solubility increases on increase of temperature. Example, solids like KNO3 and ANO3. Special case. There are certain solutions which are neither exothermic nor endothermic. The solubility of such solutions does not change with temperature. That is, there is very less impact of temperature on them. Example, NaCl, C2CrO4. Third is the effect of pressure on the solubility of a solid in a liquid. Effect of pressure of a solubility of solid on the solubility of solid in a liquid. In general, there is no effect of pressure seen in the solubility of a solid in a liquid. I hope you have understood till this. Next point is significance of solubility curves. Significance of solubility curves. Plotting solubility against temperature on a graph paper. Such graph is commonly known as solubility curve. First is steep curves. Steep curves. So if there is a graph, so the steep curves formation will be like this. Let's say this is KNO3 and this is NaNO3. So, in significance, the steep curve indicates that solubility increases rapidly with increase of temperature. Example, solubility curves of NaNO3 and KNO3 show a steep rise with increase in temperature. Second is slow rise. Slow rise. So if this is the graph, slow rise will be like this. If this is KClO3, this is NH4Cl, and if this is KBr. In significance, the slow rise curve indicates that solubility increases moderately with increase of temperature. Example, solubility curves of KBr, NH4Cl and KClO3 show slow rise of solubility with increase in temperature. Third is the parallel to x-axis. If this is the graph, it will be like this. NaCl, K2Cr O7, Cr2O7. In significance, parallel graph indicates that solubility almost remains unchanged with the rise of temperature. For example, solubility curves of NaCl and K2Cr2O7 are the almost parallel to x-axis, indicating that their solubility changes very slightly with rise of temperature. Fourth one is decreasing curve. So, in significance, the decreasing curve indicates that solubility decreases with rise of temperature. Example, solubility curve of Ce2S2O4 whole 3. Next topic is solubility of liquid in a liquid. Solubility of liquid in a liquid. So miscibility refers to the solubility of one liquid in another. When one liquid dissolves in another liquid, the solubility is usually infinite, meaning any amount of one of the liquid will dissolve in any amount of the other. Thus, we say that a liquid is miscible in another to any extent. I hope you've understood till this part 3. Let us meet in part 4. In part 4, we are going to learn solubility of gas in a liquid. In that first point, the effect of temperature. Second point, the effect of pressure, Henry's law. Then we will see concentration of solution. Then weight percentage. I hope you've understood till this. For any queries and doubt, please join the Telegram link given in the description of this video. I hope you've understood. Thank you for watching. Let us meet in part 4. Thank you.